Hey everybody, got another video here for you. Welcome to episode 2 of the barrel tuner build. The camera ran out of memory in the last episode, and I was just finishing up on trying out the new neck thicknessing jig, and it seems to have worked out great. I purposely just moved all the files off of the phone and onto the PC and fired the camera right back up and didn't touch any of this stuff so that you could see the results. Here, let me pan back a little bit. So, in the last episode, if you didn't see it, basically I built this sucker and used it along with the router in order to do the router sled thicknesser trick for neck, because I figured out that that's more or less that, and waiting for stuff to dry is the two most time-consuming parts of building one of these guitars. So yeah, here are the results, and as you can see, it worked out pretty good. Now the next step is I'll go ahead and mark out the spine and the triangular heel and see how much material needs to be removed, and figure out whether it's even worth breaking bad with the angle grinder, or whether I can just finish up with the Shinto. I'm thinking that, well, the spine's going to be about to here, so on a 90 would put it helps if I hold in the camera, doesn't it? In frame, keep it all in frame. Okay, so the heel's going to be about this big. It's only going to be about that wide and triangular, so I might want to use the grinder for a second or two in this area and maybe right along here. And other than that, probably the Shinto will take care of it all, so wait and see. But yeah, major time saver there. So I was thinking that now that it's been thinned down to 20 mil, that maybe the 45 bevel bit that I've got, following bevel bit, might be enough to do this. And so then I was thinking about, well, how would I set this thing up? And it just occurred to me the thing to do is this. So it occurred to me that you don't even need this thing. I wasted all this time making. You just take that router bit, stick it on the drill press, and then you just crank it up till the distance from there to there is, let's say, 21, 22 millimeters for a fretted neck. What you actually do, you start by measuring like this with your calipers for the calipers. So you go like this, and that gets you the thickness with the frets. And we're reading 19.71 right there. And then you go like this. See, I'm not on the frets now. And that gets you the thickness without the frets, and that's 19.67. So Those are probably not real accurate measurements. You want to take real accurate measurements. But let's say you end up with like, you're going to add 1 mil for the frets. So all you do, and if you're shooting for a 20 mil thick neck, then all you need to do is put your bit in. Pretend this is the other bit. You stick your bit in, then you measure from the bottom of the bit down to your plate here, and set it for 21 mil. And you just turn on the drill press and run this thing back and forth underneath it until you've done this. You don't need the sled. And then you take that bit out, you put this bit in, the 45 bevel bit, you adjust it so tired of stooping over for this camera that's alright, yeah. So you take it and you adjust it so the top of the bearing is right at the line there, and you might actually need to move it down a little bit, but someplace where like right about there is going to be the proper depth adjustment to get this thing to ride on the edge of the fingerboard and get you a 45 bevel cut along the back of the neck between the heel and the nut, and shape all this for you basically. Probably good enough to be ready to sand. So yeah, you would start by running it through the drill press with one of these kind of guys in order to thickness it, and then you'd run it through the drill press with one of these kind of guys in order to profile it. And so I'm going to try that next. Okay, I've marked out the neck with the spine all the way down, and the triangular heel, and where the screw hole should be, as opposed to where they used to be on the X-5, which is like 3 years ago, before I came up with any kind of standards. And so now we can actually see if the light is going to behave. Yeah, now we can actually see where there's still material to be removed. And as you can see, there's a fair amount in here at the shoulder areas still. So, but I've also set up the drill press here with the 45 bevel router bit, following router bit with the little bearing on the bottom. And I've already adjusted the table height and locked it down to follow right along the edge of the fretboard with the bearing, and to start cutting just above the edge of the fretboard or right at the edge of the fretboard. That's the tricky part, because see, if you like tilt or wiggle this thing a little bit while you're doing this, then if you tilt it like that way, then you're actually going to start cutting into the bottom edge of the fretboard a little bit probably. So you got to be careful and slow with this process probably. But down at just kind of like sliding it along as a, with the power off as a dry run test to check it out. It looks like it'll be, I don't know, it'll be somewhere down here before it really starts to actually have any effect, I think. So, but I'm going to give this a shot. And I think I already mentioned this in a previous clip, but if you take this bit and use it instead of that and adjust the table to the proper height, you don't even need this thing. So yeah, I would have to say that going forward, that using the drill press and using a bit like this, they make nice big ones that you'd be able to like do a whole neck in like one pass kind of thing. Use a bit like that in order to thin it down to 20, and then use a bit like this in order to get the profile. Might be the way to go. We'll see how this goes. All I gotta do is I've got this plugged into the generator. All the big gear gets plugged into the generator and run off the generator. Always, they drain batteries way too fast. Induction motors. So yeah, let me go fire up the generator and we'll see what happens. Well, so much for that. I think I'd have to say that the angle grinder might be quicker and easier. This isn't a real milling machine like they have at Texas Toast, so. Well, since the drill press didn't do so well with this thing, it's probably not a good idea to use this thing on it either. Which means that this thing is still has use. This and a real router. Well, I think I'd have to say that it works, but it's not really fast or easy, and also this isn't 45. These cuts are 45-degree angle, but the angle, if you go from here to here, this angle is not 45 degrees. It's something less than 45. So you would need, in a router bit, you would need something like a 60-degree router bit, maybe. You'd have to like do part of it. Up here, that's where the neck is actually 45. And then here, it requires a larger angle router bit, 60, something like that, maybe, the rest of the way. So, yeah, looks like angle grinder and a 40 grit flapper disc, sanding disc is going to be the way to shape this thing, I'd say. And you just like go from about here down to maybe there, and that's it. So just, yeah, at this point, this thing only needs like, like one swipe right here and a couple swipes right in there and there, and it's ready to go for shaping with the Shinto rasp. So yeah, just a little touch-up work with the angle grinder, and this should be ready to go. And going forward, it looks like the angle grinder is going to be the preferred, is going to be the weapon of preference, shall we say. I think that's going to do it for the angle grinder, and all the rest of it is just finishing up with the Shinto rasp. All done. I tried a draw knife, it was slower than the rasp. I tried the trim router with the collar off, and the regular, the leveling bit that I used before, just the regular side cut bit. And it's too aggressive and it's too hard to control. So yeah, Shinto rasp, it wasn't bad, it didn't take that long. So it's ready to sand. All done sanding. Electric palm sander, quarter sheet sander. Didn't take too long. Didn't take too long. Definitely faster than hand sanding. Not sure how long it took. Definitely under an hour. Probably under half an hour. Yeah, turned out nice. So this thing is more or less ready for the paint shop. And now it needs a body. So, to design a body, we need one critical dimension off the neck first. And that is the actual length of the neck from the nut to the end of the heel. And to get that, it's pretty straightforward. Get your meter stick, start up with the nut, and measure the length of the fingerboard. Survey says, try to be accurate about things, go down the middle. This is clocking in at 490. Let's call it 493. And then the second dimension here is the amount of overhang. And that's going to be 8. So we take 493 and subtract 8 for the overhang, and we get 485 for the neck length. And that's the number we need to know in order to lay out a body to fit this. So here's our triangular heel, and it's going to be 40 wide and 90 long. And this is where the end of the neck is. So down here is going to be our saddle line. And the saddle, it's going to be, it's a fender scale length, so we're 648 from the nut all the way up here to the saddle line. And we know that the neck down to here is 485 already. So 648 minus 45. You crunch that on a calculator or whatever. And survey says this distance is 163. From the end of the neck to the saddle line. So, taking a look at a barrel tuner here, we've got a, I was thinking this actually screwed in and you would rotate it in order to adjust the height up and down, but it's got a lock grub screw there, and it's not threaded, it's just a post. And it actually has little miniature grub screws here to raise and lower it like it was a fender saddle with a little Allen. So, yeah. So, that's how you get your height adjustment on the saddles. And this one down here unlocks it from the base so it'll slide back and forth for your intonation. And it's currently in the all-way forward position. And looking at the saddle in general, if this is your saddle line right here, and you start with your guys all the way forward and have your saddle line right there, then you're going to need wood back to enough to mount these two holes on the base. So I'm thinking from the saddle line, you want wood back to about where the knobs start. So we're looking at something kind of like this. And yeah, so here would be our saddle line, and there's our saddle. And so our wood's going to extend from the saddle line back to there. Let's get a measurement. Survey says 50 millimeters. So we're going to come down another 50, which would be about a third of this. And that'll be the end of the guitar. And these things are designed for 10 millimeter spacing. So our bridge, quote unquote, will be 60 millimeters wide. So we need 60 wide for the saddles down here. Okay, and then you're going to need the bar down on the right side that lets you mount the EQ and the control panel, and also serves as the right hand portion of the leg cutout, you might say. This bar down here and then the swing bar form the leg cutout. And on an X-13, that distance, the length of this bar here is 200 millimeters from the saddle line to the end of the bar. And so that's probably a pretty good length to work with here as well. And then the bar is like 20 millimeters wide. So we'd have 60 millimeters here, and then we've got a bar coming down from the saddle line side. And that's going to be 20 wide. And this distance is going to be 200. So that's 50, so this is 150. And then it's a matter of, that's 20 wide, so that's 20 wide. If we make it like symmetric, then we add another 20 here, which makes this whole thing 100 wide. So you're like 100 wide here, and you connect the dots. Now, do we go 100 wide and keep it symmetric, or do you just go 60 wide here, or, I mean, the other way to do it would be you make it asymmetric. You've got 60 like that, and then you have this side comes like this, and this side comes all the way out like this. It would be the other way to do it. That would make the whole guitar only 80 wide. Where are we at here? 80. That's rather narrow versus 100, which still isn't bad. Maybe I should make scale drawings of both to see which one looks better. So here are a couple different options. We got our triangular heel here. This is a 1/2 size scale drawing. Got our triangular heel up here. These are the tuners here. Those are the knobs. So at the very minimum, you're going to need like what's here on this green line. Then this is the bar back here. And then you'd need this dashed red line. And that actually I think is the sleekest shape and the one that I'm probably going to go for. Other options, you could carry this out to be 20 mil wide all the way to the front of the top of the tuners, and that would be this outside green line. And or you could do the same thing on both sides, and that'd be this outside blue line. You could even like go like that and then bring this back like that, which would also look kind of slick. But I think the green line on this side and the dashed red line on that side and the bar, which is the absolute minimum, is what I'm going to do. Change of plan. Forgot a strap lock, so you need 20 mil wider than the tuners on this side for the bar, and you need about 20 mil wider than the tuners on this side for the strap lock. So just make it 20 wide at the back. That'll definitely clear the front if you just run a line straight from the triangular heel all the way back to the back of the tuners where the end of the body is there. And so yeah, I think the red lines is the way to go. Red lines plus the green bar down here. Keep it simple, right? I was thinking ahead about like controls and control panels and stuff. It's only going to have 6 mini toggles on it, so hopefully that won't be too intense in the way of a control panel. And I don't want to get into a second bar here because A, it complicates things, and B, it could get in the way of access to the tuners here. So, and if 6 minis here seems to be an issue, I can always put a back cover plate on it that goes on with pickguard screws, and then mount like the battery box to the back cover plate. And then you could remove the back cover plate in order to access the electronics, and when it was installed, it would protect the electronics from behind. and you can still see your cool electronics from the side. So that means we're going to need a 100 millimeter wide body blank, not an 80. And I added up. You got 90 for the heel, 163 is our magic number from the heel to the saddle line, and then we got an extra 50 for the tuners and 150 for what's left of the bar past the tuner, past the tuners. And it adds up to 453 total. So you need a 453 by 100 body blank. Okay, I found some wood of the appropriate width. It was either this or red oak, and this is clear New Zealand pine. And this is going to be much easier to work than red oak would be, so I'm going to go with this. There was also knotty pine to choose from, but I figured I'd use it the last of the clear. And everything else was either not wide enough to get both a body and a swing bar out of, or it was much wider than I need. So, like, you know, this is a 1x6, and the cedar's 1x8, and everything else is like 1x12, so this looks like the best choice for the least amount of wastage and stuff like that. And there's absolutely nothing wrong with pine. It's perfectly fine tone wood. So I have a body blank, and the next step is to mark it out. And basically I'm going to draw a center line and then transfer this full scale over onto the wood, and then I'll be ready to have at it with, I don't know, circular saw, jigsaw, whatever. And yeah, so I'll be back once I finish marking it out. Okay, I think that's going to do it for this video. So until the next one, everybody, have a good one.